Welcome back to my YouTube channel, Computer Network Basics. Now we're gonna talk about tunneling in networking and BGP. Tunneling in network encapsulation. A data packet is wrapped in additional header, forming a tunnel that carries it through the network. Types of traffic. Supports transporting non-IP protocols, IPX, MPLS, or private data like VPNs over public networks like the internet. Security, often combined with encryption to protect data from eavesdropping, as in VPN tunnels. Common protocols. Examples include GRE, IPsec, MPLS, and SSL/TLS tunnels. Types of tunnels. GRE, generic routing encapsulation, simple encrypted tunneling. IPsec, encrypted and secure, often used in site-to-site VPNs. SSL/TLS, used in clients with VPNs or OpenVPN or any connect. L2TP, often combined with IPsec for securing tunnels. As you can see in the diagram, that's how the tunnels works. And now we're gonna do a demo and packet tracer about tunneling. Now we're gonna do our tunneling. What I did here was make a visual presentation of what the tunnel would look like. As you can see with the tunnel 1. And now we're going to need two new IP address for both ends of the tunnel. And it's going to be 192.168.50.1/30 and 192.168.50.2/30. And they need to be in different networks than the network that are on the original router. So for the end that connects to router 1 and connects to router 3. And this is the command where we are going to be using. And now let's go to the router 1. Disable, configure terminal, config mode. And we're going to do interface tunnel 1, as you can see in here, to create the tunnel. Enter. And now we're going to add the IP address, which is 192.168.50.1 with the subnet mask of 255.255.255.252 because it's a /30. And we're gonna go to the router 3 and make the interface for that router. Configure terminal, interface tunnel 1. And for this tunnel, I'm gonna use this IP address. And the IP address is 192.168.50.2, 255.255.255.252 because it's a /30. Enter. And I'm gonna go back to the first router and I'm gonna type tunnel source. Tunnel source is going to be the interface that leaves the network and goes towards to the router 3. So that's going to be this interface, giga0/01. So the command is tunnel source gigabit ethernet 0/0/1. Now I'm gonna type tunnel destination, and the IP address that we're gonna use for our tunnel destination is going to be the IP that reaches router 3 from our network. And that's going to be this IP address 20.0.0.2/30 and click enter. And now we're going back to router 3 and now we're going to configure the tunnel source and the tunnel destination. And the source for that is going to be that interface, and it's going to be a giga0/0/1. Press enter. And the tunnel destination is going to be the 10.0.0.1/30. Then we're entering that. No, sorry, you don't need to add that subnet mask, just the tunnel destination. Enter. To exit, and to verify we can go for show IP interface brief. As you can see, the tunnel 1 is 192.168.50.2 and it is up and up. And for router 1, it says tunnel 1 192.168.50.1 up and up. And for router 3, and the tunnel 1 is 192.168.50.2, yes, manually up and up. And that is how our tunnel is up. Now we try to ping our tunnel 192.168.50.1. As you can see, the 2 ping did not go through, but the other 3 did go through. But if we do it again, it should be 5 out of 5 right here. And we can also go to router 1 and ping the other tunnel, the tunnel 192.168.50.2. As you can see, it goes through, is a success. So in the end, the data is taking the top route, but the IP that being sent is this IP address. This is what VPNs are all about, and that is tunneling. Now that we're done with the tunnel, we're gonna talk about what is BGP. BGP is a border gateway protocol. Is an exterior gateway protocol used to exchange routing information between autonomous systems on the internet. It enables efficient and scalable routing across global internet, ensuring connectivity between organization and ISP. BGP operates over TCP on the port 179 and use path vector logic to advertise routes and prevent loops. It supports policy-based routing, allowing administrator to control route advertisement and traffic path. Why we have BGP? BGP's purpose is to exchange routing information between different autonomous systems on the internet, ensuring end-to-end connectivity. It determines the best path for data transmission based on routing policies and attributes like ES path and local preferences. As you can see, an autonomous system, that is the diagram of BGP. Now we're gonna do a packet tracer configure. We're gonna do our BGP in packet tracer, and now I'm gonna show you how to configure BGP. This is our topology. We have this autonomous system here, it's 100, and ES stands for autonomous system, and we have our autonomous system here, ES 300, and the autonomous system over here is 200. The IP has been set up, the routing has been set up, everything can ping one another. We're just gonna configure the BGP aspect. This commands router BGP right here is gonna be the commands we'll be using. This router BGP autonomous number is what create autonomous system, and then you're going to type the neighbor with the neighboring IP with the remote autonomous system number, and then you're going to type network address followed by your network subnet mask. So we'll do it one by one. First, we're going to the router 1, CLI, enter, enable, configure terminal, and I'm going to type in router BGP 100 because we're in autonomous system 100 to start. So there's a router BGP 100, enter, and then you type in neighbor, followed by the neighbor IP address. So for router 1, so the neighbor IP is going to be this IP, the 10.0.0.0/30. And the IP address that I put it in G00 is going to be 10.0.0.0.2. So we're gonna type 10.0.0.2, and we're typing in remote-es, and we're gonna type in the remote autonomous system number, and it's going to be 200. So we type in 200 and enter, and then we're going to type in our network address, and our network address is going to be 192.168.1.1.0/24, and 192.168.1.11.1 is going to be the default gateway, and we're gonna add mask, and the mask address is 255.255.255.0, enter. And now we configure this router, and now we're gonna go to the next router, which is router 3. Press enter, enable, configure terminal, and for this part we're doing autonomous 300. So we're doing router BGP 300, enter. And so the neighbor is going to be 200, autonomous 200. So we're gonna add neighbor IP remote as number 200. And so the neighbor IP address is going to be 20.0.0.1, and then we add remote as, and remote as 300. Oh, sorry, 200, because 200 is the autonomous system number. I'm gonna enter that, and we're gonna do the final one. It goes to the network address mask and subnet mask, and the network address is going to be 192.168.32.0 with the mask of /24 255.255.255.0. Enter that, and we're done configuring the router 3. And now we're going to do the routing 2, and we're going to configure terminal, and we're gonna type router BGP 200 because the autonomous system is 200, enter. And we're gonna type the neighbor IP address, which is 10.0.0.1, and remote as 100 because the autonomous system is 100, and we enter that. And as you can see, we have the notification saying that the neighbor is up. And now we're gonna repeat this command, and I'm just gonna delete the 100 and add 300 to link this network, and I'm gonna replace the IP address with neighbor IP address is 20.0.0.2, and you press enter. As you can see, it says neighbor 20.0.0.2 is up, and to verify we're gonna do and show IP BGP, and as you can see, the BGP is on the router. We can also type in show IP BGP neighbors, and when you run, you want to make sure you see the BGP state. And as you can see, the BGP is working because if you try to ping PC2 with the IP address of 192.168.32.2, you get the reply. As you can see, we were able to ping, and the BGP state is established for router 1, and for router 2 it is established, and for router 3 it's also established. And that is how BGP works. Alright, overall, BGP provides routing between tunnels endpoint. Without BGP or static routes, the tunnel source destination cannot reach each other, keeping the tunnel protocol down. Once BGP advertises the network between routers, the tunnel endpoints become reachable and tunnel comes up successfully. Thanks for watching, and I'll see you next time.